Well, good day and welcome to our webinar this morning or this day on egg turning. Welcome also to our Spanish-speaking customers. Bienvenido también a todos nuestros clientes que hablan español. La próxima semana tendremos la misma clase. Si desea verlo en próximo martes en lugar de hoy, puede visitar www.chickmaster.com y registrarse ahí ahora. My name is Mark Sintel, and I'm the Vice President of Customer Care for Chickmaster, and I'd just really like to welcome everyone here. I wish we could see you in person and look forward to that day coming soon, but we're really honored that you would join us today virtually so that we can connect the best way we can. I was able to review this webinar yesterday with the team, and I learned so much about turning that I didn't know. I thought maybe this is as simple as, gosh, 38 to 45 degrees that way and 38 to 45 degrees that way, but no, there's so much more to this topic of turning, and I hope that you're going to learn a lot today through the course of this presentation. If you have questions during the presentation, feel free to use the Q&A button at the bottom of the screen. And then we'll address those throughout the presentation and then at the end as well. So use Q&A and not chat, use Q&A to ask your questions. Our presenter today is Craig Harrison. Craig leads our global training team, and he also provides customer care leadership in Europe, the Middle East, and Africa. And he's arguably one of the best troubleshooters and problem solvers in our industry. And so I hope you'll use this hour that we have with Craig to kind of glean from his expertise and improve your incubation performance. Some of the other Chickmaster staff is also standing by to help answer your questions through the Q&A button. But without any further introductions, I'd like to give you Craig. Craig, welcome.
Thank you, Mark. So as Mark mentioned today, we're going to spend a little bit of time today going through turning systems available on our different line of incubators. So today we're going to cover two main products. The two mainline incubators that Chickmaster sells, as you're aware, is the multi-stage incubator, or the Classic, and the single-stage incubator, which is based around the Avida, and then the various control options available to that. So first of all, today we're going to touch on what would you expect to see in a hatchery if your turn angles are causing a problem. So these are the first indicators that you guys are going to see on a hatchery level or on a farm level that may indicate that you've got a turn angle that's going to need correcting. Once we've gone through the details of that, we'll touch some basics on some very basic entry-level embryology on exactly what's going on within that embryo as it develops and inside the egg, and why is it we're turning the egg in order to achieve that end. Once we've covered those topics, we're going to stop by the potential causes of bad turning for the different control options that we've got available. And then as we touch base on each of those issues, we'll run through some remedies on how you correct those options. Although we're touching the two mainlining products that Chickmaster sells, there are a couple of turning systems out there, mainly on our legacy machines, the older machines that are 15 to 20 years old. And we're not covering those machines today purely because there's not many of them around in the world. But if you've got a turn system that isn't covered today, by all means drop us an email at support@chickmaster.com or drop a comment in the Q&A box, and we'll see if we can address that today or speak to you offline after this webinar. So what happens if you don't turn? The most noticeable impact that you're going to get on your developing chicks is a lack of adequate development of the cationic membrane within the inside of the eggshell. This is going to have a direct and measurable impact on the growth of the chick, which is going to result in a smaller, slower growing chick. This is going to give you far higher early mortality on the farms when you put them out to the grow-out farms, and also worse feed conversion rates and slower growth rates. As a direct result of this, those birds are going to be weaker. That leads to a direct impact on higher incidences of sickness on farm and issues with bacteria and infection. The turning system also has a measurable impact on the development directly of the chick itself. So if you're not turning either adequately to the correct angle or frequently enough in the incubators, certainly in the earlier stages, that's going to lead to issues with malpositioned chicks, which can lead to a lot of late dead when you're doing your residue breakouts, and also fatigue chicks, and that's indicated by bulging necks as they're struggling to pip out of those shells. One of the lesser known reasons or lesser known problems that can come from a deterioration in turning control on your machines is deformed chicks. This is almost an indirect result of turning in the machine and is often caused by lack of uniformity within the cabinet due to the airflow changing within the cabinet. As part of the development of the chick, you can also end up with a high number of late dead due to the incomplete yolk absorption into the chick. So within those last few days of the incubation cycle, usually you see that yolk absorption into the bird, which gives it that fuel for the first few weeks of life. If that hasn't been developed properly, the chick's going to have problems with unhealed navel and infection again when it gets out to the farm. Lack of good turning, as I mentioned a moment ago, will have a measurable impact on incubation uniformity. The reason this is a problem is if you're not incubating uniformly across your incubator, whether it's single stage or multi-stage, that's going to have a direct impact on your hatch window and the quality of the chick that your machines are able to put out. So when you're looking at your day-old chicks, whether it be in your chick processing room or a couple of days later on the farm, you're going to see a discrepancy between the larger chicks, the smaller chicks, the healthier chicks, and the unhealthy chicks. Because of that lack of uniformity inside the machine, it can lead to two problems. Warm spots, which is going to lead to missing limbs, missing eyes, exposed brain and viscera. And then the other end of the spectrum, because of colder spots within the incubator, you can have what we call deemed green chicks during takeoff. So these are chicks that haven't fully completed their incubation cycle and aren't fully ready for the world. And when you come to transfer them from the machine, they may still be in the egg because they haven't completed pipping. Or when you do transfer them out, their chick down is still quite damp, and that leads to a lot of evaporation and it tires the chick out and stresses it. Because of the lack of uniformity in the machine, it can lead from turning. You're also going to have a larger hatch window, as I mentioned earlier. That's going to have an impact on your operation in the hatchery. So if you're expecting to take birds off at say 3 o'clock in the afternoon or 7 o'clock in the morning, but your hatch window's been elongated by 4 hours, you're not going to have those birds ready. So all of your operations, your trucks and your deliveries are going to have a knock-on effect. This graph here, provided by poultryworld.net, shows you very clearly the result. So on the orange bars, you can see the hatchability analysis of a set of flock that is turned adequately. And the green bar shows you the result of a flock that doesn't receive any turning within the incubator. So straight away, you can see the fertile hatch drops from around 86 to 87% all the way to below 50%. And that's at the very extreme of no turning in your incubator. If you've got maintenance problems, wear and tear, or an electrical breakdown inside your incubator, you're going to find that drop in hatchability is somewhere between those two extremes. So why do we turn eggs? The main reason for this is nutrient transfer. Secondary to that, and almost linked with it, is embryo development. And then the tertiary reason, which is the one that's often overlooked, is for incubation, is for uniform incubator airflow. So we're going to quickly touch on 3 of these before moving on to the mechanical causes of deterioration of those. So when we say nutrient transfer, what we're talking about is the development of the vascular system on the internal side of that eggshell. This is the system by which the embryo collects CO2 from the ambient air around the eggshell, so is it within the cabinet provided by the area system of the CC3, and disperses CO2 from inside the shell to outside, which is then exhausted. If that cationic membrane, or the CAM for short, isn't fully developed because your turning system isn't operating to full specifications, it reduces the capability of that egg for the transfer of the gaseous. The result of that is a direct impact on the development of the embryo. The skeletal growth of the chick is also driven hugely by the calcium drawn in from the eggshell itself. So a reduction in the ability to obtain that calcium has a measurable impact on the density and the growth rate of the skeleton of the chick. Secondary to nutrient uptake, you've got the embryo development itself. So within the embryo itself, the embryo, as in very early stages, within the first 3 to 4 days, it's going to put out a series of veins to draw the nutrients from the very nutrient-dense yolk inside the egg. Now, it requires these nutrients in order to grow. So if you're not turning adequately and it doesn't grow that quickly, you're going to have an embryo that's unable to get access to the nutrients that it needs to grow. That membrane is also very important in the latter stages of incubation to completely absorb that yolk into the navel of the chick in the last couple of days. So if it doesn't grow and develop correctly in the early stages, you'll have a noticeable difference in the latter stages as well. So 20, 18 days further down the line. The other side of the embryo development, which is directly impacted by the turning system, is the position of the chick within the egg. Everybody here, I'm sure, is aware the correct position of the egg for hatching is the large egg up. So that's the side of the egg with the air sac at the top, and that's where the chick's head needs to be for it to hatch. In addition to that, the turning system allows the chick to turn within the egg and position itself correctly so the head is at that fat end with the air sac. In addition to that, the turning system allows the chick the opportunity to get its head under its right wing, which is where it needs to be for that pipping muscle on the back of its neck to allow it to give it the strength and the position to get out of that egg. If that isn't in place, what you're going to find is a chick that's unduly stressed and maybe with an embolism within that muscle on the back of its head. And that's something, again, you can see very readily on a residue breakout. And the tertiary reason why we turn the eggs within our machines is to encourage uniform airflow within the cabinet. When the egg mass is turned correctly, so through to 45 degrees, that acts as an intentional restriction to the airflow within the cabinet. Now, the reason we do this is it encourages uniform airflow through that egg mass. If the air had free rein to travel any way around the incubator that it wanted to, it would take the path of least resistance every time. The result of that is a lack of uniformity, and you may find that the bulk of your air goes down one side of the machine and a small minority goes down the other side. What that ends up happening is you'll have some eggs that don't receive conditioned air and some eggs that receive lots of conditioned air. Now, the ones that don't receive any air in the exothermic stage of incubation are going to overheat, and the ones that are receiving lots of cool conditioned air are going to be considerably cooler. And that again goes back to that larger hatch window and the risk of deformities within the developing embryo. So on this slide, it's a quick demonstration, just showing you the difference in spacing. On the left-hand side, you can see an egg flat which is turning at 45 degrees. The amount of space between those flats is greatly reduced, but you've got ample space down the side of those egg flats for the conditioned air to circulate around the entire egg mass. The diagram on the right-hand side, where the egg mass is only turning to 25 degrees, which is an extreme example of a deteriorated turn angle, you can see that the spacing through the egg mass is that much larger. So what we'd often see in a hatchery in this situation is a lot of conditioned air going down the top of the egg mass or down the bottom in a classic, and very little going through the rest of the mass. So you'd find eggs at the top that are maybe half a degree warmer than the eggs at the bottom, and that again is going to cause two malpositioned deformities in a larger hatch window. So what causes these bad turn angles? By and large, with broad strokes, you can narrow this down to three main causes. The first of these is configuration of the machine. So when we're talking about configuration, we're talking about the physical setup of the machine. So this is something that our engineers would handle whilst they're installing and commissioning the machines, and something that you can readily check on something like a preset checklist. So this is just ensuring that the hardware on the machine and the control on the machine is adequately set up as it's designed to do. The second reason that you're going to have deterioration in turn angles is mechanical wear. So this is unavoidable wear and tear on your machine caused by mechanical friction between any competing materials. So metal on metal, metal on plastic, anything that moves in connection with something else is going to have an amount of wear on it. The third reason is largely electrical breakdown. So this is where your reactive maintenance comes into it in the hatchery, and we're talking about things like limit switches and actuators that are physically breaking because they're at the end of their life, or they've received some external damage to them. So we're going to spend a couple of minutes on each of these points for each of the turning systems available, just to go through in a little bit more detail how you'd spot these problems and how you'd resolve them. So on a classic setter, the turning system is driven by a couple of main components. In the roof space as you go through the door, you're going to find a large single-phase motor. This is a rotary motor that just turns one direction until the end of time, stopping periodically when the turning system is not needed. This in turn is connected to two sprockets, a larger one with 40 teeth and a smaller one with only 17 teeth. These sprockets have to be aligned correctly, and this avoids you putting undue stress on the rest of the turning linkage. Now the chain that connects these, much like a chain on a motorbike, has to be tensioned correctly. This is done through the screw block, which you can see is number 3 on the drawing on the right hand side, and you just tighten up the screw on the underside of this to take out any slack in that chain. And what you're looking for on that chain is to ensure that there's no slack, so that the chain doesn't run the risk of coming off the cogs at worst, or slipping on the cogs. If it does come slipping off the cogs, what you're going to find is, because of the weight of the egg mass, which always wants to self-right within the trolley or within the tray frame, you'll find if it does slip, you're going to catapult some eggs and you're going to bump them out of the egg mass. So if you're periodically finding a handful of eggs on your floor, the first thing you really want to check is the tightness of that chain, and just look at tightening it up a little bit more. Next to that, you've got a series of limit switches denoted by 4 and 5 here. Now, those of you with classic machines that are slightly older, so maybe 15 to 20 years old, will find that they only have one limit switch for the level position. Sorry, one limit switch which gives you your extend and retract position, and you don't have the limit switch for level, and you have to manually drive it to level. On all the newer controls, you've got that second switch, so you can automatically do from the touchscreen to set it in level. Those micro switches are driven by the cams you can see slightly above that on that shaft next to the larger cog, and they've just got some indents in that cam, and they trigger the switch. So whilst we're commissioning that system, we'd set them in place and tighten the grid screw up on the shaft to set them in that position. If for some reason they come loose and slip, you may find that your turning system doesn't stop either at level or doesn't stop correctly at 45 degrees each way. If that's the case, and your chain's correct, your sprocket's correct, your motor's correct, you want to really be looking at those cams and the position of them to ensure that they haven't slipped. Once you make it past the sprocket and chain alignment, then you want to be looking at the crank arm and the pitman bar inside the machine. Now the crank arm, it's important when this is turning to 45 degrees fully extended and 45 degrees fully retracted, that the position of that crank arm is 9 o'clock and 3 o'clock as you'd look on the clock face. That is fully to the left hand side and fully to the right hand side. That gives you the maximum possible movement of the pitman bar in those locations. Equally, if you set up the turning system that isn't in those positions, when you do turn the motor on and it seeks to go to those positions, you're going to find that it overturns those eggs ever so slightly, and you run the risk of crushing some eggs, which is something you absolutely want to avoid. Once you've set that crank arm up correctly to the limit switches, then you want to be looking at the pitman bar and the adjustable screws on the far right hand side of that, denoted by the number 1 on the top right corner of this picture. And that's how you set the aggressiveness of the turn angle. And what you're looking for is to even out the turn between the left-hand side and the right-hand side, so that the distance between the turning arm and the power gam, which you can see by the red circle on the bottom of this picture, is equal on both sides. Now, once you've got through the configuration of that turning system, on a Classic especially, that's going to turn until the end of days quite happily, unless you manually stop it in order to transfer eggs or load fresh eggs. However, as with any mechanical system, you're going to get an amount of unavoidable wear and tear, but this is all wear and tear that's easy to identify and easy to rectify. So any metal on metal joints, especially at the top of the hanger bars, which you can see in the picture on the top right corner with the 1 in it on this case, is going to have an amount of wear. So this is this is unavoidable wear, where you're going to find circular holes become elongated and turn into ovals. The net result of that is, although your turning system might still be turning to 45 degrees, your egg flats further on down the system are only maybe getting 38 or 37 degrees. And as soon as you get below 38 degrees, you're going to have a measurable impact on your hatchability. Now, as well as your hanger bars, which is where your main wear is going to come from, there's also a risk of wear and tear damage in that machine as well. So this might be where trays haven't been loaded correctly into the machine, and you've got a physical jam inside that machine. Now, whenever you stop the end result of a mechanical system from functioning, somewhere down that chain between the motor, the chain, the sprocket, the pitman bar, through the crank arm and down into the hanger bars, something's got to give. Something's going to physically break in order to relieve that tension. Now, 9 times out of 10 for a classic machine, it's the pitman bar that's going to go. Now, the reason for that is it's the easiest to replace in the machine. So that's a built-in weakness in the pitman bar, so something that you can nice and easily replace. Now, the problem with any metal system, as soon as you bend it once, you weaken the inherent structure of that material. So trying to bend it back by hand and putting it back in the machine isn't really an acceptable solution for that. What you want to be doing is getting a replacement part and swapping out in the machine so it's good as new again. Now, an electrical breakdown on a classic machine is actually fairly simple. There's very few control components within this machine that can go wrong. So from a control output point of view, you've got your PLC, or you've got whichever control platform you've got in that machine, and that's what tells the turning system once an hour, or whatever you've set that duration to physically turn the machine until it sees that limit switch. Because the PLC is a low voltage and the motor on this is a high voltage, you've then got a relay interface that translates that low voltage signal to a high voltage signal, and then you've got the motor inside the machine itself. So really, you've only got 3 components there to physically get the machine to turn. But in order to do that, you also need feedback from those limit switches, which tell the control where it is. So if your turning system isn't starting for whatever reason, you want to be starting at the top of that list, your PLC, to ensure that it's giving that signal out. And then work your way down the list to make sure your relay is activating, and that's giving it a high voltage, and then to see whether your motor's turning or not. And on this picture, you can see a capacitor on the motor. 9 times out of 10, if your motor's not turning, you're going to find out that it's either the relay that's gone or it's that capacitor. Now, an Avida turning system is a little bit more complicated, but just as easy to understand. What we're going to run through first is the bottom turning system on an Avida. Now, there's 2 options available. We've got the bottom turning, which is driven by a pneumatic actuator, and a top electromechanical actuator, which is mounted up on the roof, which we'll get to in a moment. Now, the bottom turning actuator is mounted centrally in each zone of the machine. So on an A12 machine, so that's a machine with 12 trolleys and 2 zones for control, you're going to have 2 sets of actuators. One actuator in this first zone, which will control the turning of 6 trolleys, and a second one for the next batch of 6 trolleys in zone 2. If you've got a Gen 4 control, is denoted by picture 2 in the top right corner here, you're going to find yourself with 3 limit switches. Now, these limit switches are magnetic reed switches, which are triggered by a magnetic band that runs down the inside of that actuator. So as that magnetic band travels up and down the shaft of that actuator through the stroke, it triggers those reed switches and lets the control know exactly where in that turn system we are. If you've got a newer rock control, we've replaced those reed switches for ease of use with an inclinometer. Now, that inclinometer gives us a 4 to 20 milliamp feedback, and it gives us very accurate information on exactly where in that stroke that turn system is. And the advantage of that compared to a Gen 4 system is it allows you to alter your turn angles on the fly, which is really handy if you suddenly find yourself setting eggs from an older flock, so the eggs are a little bit larger. So instead of 45 degrees, you only want to maintain 43 degrees, so you're not squashing those eggs at that upper extreme. Now, in conjunction to those limit switches, the other important part of the configuration for this is the mechanical stop. Now, the mechanical stop is built into all of our bottom turning systems, and it's an M18 bolt on the underside of those cross beams you can see arrowed at number 3. Now, this is a bolt which is a height adjustable, and it physically stops that turning system from going beyond that limit. And that's something our engineers would set up, and we'd nylock those in place, we'd thread lock those in place, to ensure that if something went disastrously wrong with the control, or a user came up and didn't know what they were doing with the screen, that turning system physically can't turn enough to damage your eggs or to damage the machine as a larger whole. Not shown on here is the height adjustment of the turning assembly itself. So in order for us to be able to achieve and to adapt the turning system for undulating floors, so that's floors that aren't perfectly straight, we've got packers available on the turning system on the shoes. So we can raise one corner or the entire assembly as needed. That allows us 2 great bits of flexibility. The first is for floors that aren't completely flat, as I've already mentioned. And the second is, as the machine ages and your casters get worn, you can lower the height of that turning system to accommodate the fact that your casters are lowering the height of that egg mass. Now, your mechanical wear on your bottom turning Avida is next to non-existent. The pneumatic actuator itself is pretty much maintenance free. The two main things you want to look out for, and this is once every 2 years or so, is your mechanical seals on the inside of that rod. And this is mainly an issue if you don't have a filter or a condensator on your compressor supply. And you also want to take that actuator apart and just re-lubricate it every now and again. Now, the lubricant that we use is something called Magna Lube, and it's a non-water-based lube for life, is what they call it. So in an ideal world, you put that in and you'd never need to touch it again. However, the turning system is absolutely critical to doing great incubation in your hatchery. So I would still take it upon yourselves to strip these actuators down periodically, and we're only talking once every 24 months, and just check those systems for damages, re-lubricate, and replace the seals as needed. The cost of a replacement seal kit for these is somewhere in the region of $20 to $25, and it's about a 30-minute time investment as well. In conjunction with the possible wear on the actuator, you've also got your normal wear points on your trolley. Now, the big advantage of a single stage, newer Avida trolley is all of the mechanical wear points come with nylon bushes at the top of the hanger bars and on the link bars. Massive advantage of that is 5-10 years down the line, when you're starting to get wear on your trolley, instead of having to replace lots of metal work on your machine, on your trolley rather, all you need to do is pop out the old bushings, pop in some new ones which are really cheap, and your trolley's back to the quality that you bought it at. Now, Avidas, as mentioned earlier, have got another option. Now, this is a far older turn system, which is still current. It's still a very good turn system. It's just slightly different ethos and different control philosophy with it. So picture one at the top here. You can see electromechanical SKF actuator. That's actually been superseded by a Warner, which is a black actuator. Fits in the same footprint, has the same wiring, has the same control. It's just a slightly different actuator with some control enhancements to it. And we've got a picture of that a little bit later on. That actuator is a linear actuator. So that just goes out and in all day long. We transfer that to a rotary action for the turning system using a series of linkages along the top of the roof. So number 2 here, you can see a link bar which connects that actuator down the length of the machine. And then coming off from that link bar, at number 3, you can see a crank arm which turns that into a rotary action through the bearing block, which is a little brass bearing you can see at the bottom of number 3, through into the rocker arm, which is on the inside of the machine at number 4. All of the parts of this are really important, but it's worth noting here that number 2, that actually shows a bent link bar. This is something that's much like the Pitman bar in the classic turning, it's built to fail. So if you have a mechanical failure within the machine, that's going to be one of the first components that bends, and the entire purpose of that is the amount of torque that actuator will give out is astronomical. It's huge. If allowed unchecked because of a mechanical jam, that actuator will tear itself apart. It'll tear the machine apart. So we've put a built-in weakness, something that's easily accessible and easy to swap out. So should the worst happen, you just need to replace that link bar. Not shown on this picture, in fact, it would be just below where the number 1 is a capacitor, which is required by the SKF actuator just to give it the current for it to initially start. And we'll touch on that again in a bit more detail later on. So here's just a different view showing the exploded view of that turning system. So on the far right hand side, you can see the actuator in the top right corner. That's connected to the link bar, which runs down the length of the machine, as I said. And then that link bar connects to your crank arms, through the bearing block in the machine, and through to your rocker arm. Now, this is the best picture I've got of this, but you can see in the middle of this picture at number 4, you've got that bearing block. There's 2 M8 bolts that hold that down through to the roof of the machine. It's important that those bolts are kept tight. If those bolts come loose, it gives you a little bit of slop in that bearing, and you're going to lose turn angle between the crank arm and the trolley. The trolley's got an inherent built-in resistance to it because of the weight of the egg mass in it. So if that bearing block is loose, it's going to move, and it's going to deform the turn angle between the top of the machine and the inside of the machine. So as part of your preventative maintenance, as part of your periodic checks on the machine, that's something that you absolutely need to go around and spot in the machine. And when you're going around on the machine, what you're going to find is those bearing blocks are along the machine just here, and you get access to them with like a long-nosed Allen key. Now, when you're configuring a top turning Avida, the first thing you want to do is to set those turning shoe heights. So those rocker arms are not a complete unit. Those turning shoes actually are adjustable, and they're adjustable for a couple of very good reasons. The first is to accommodate for undulating floors, and the second is to accommodate wear and tear on the trolleys. So when we first set up the machines, we'll set them all up as with full trolleys, because full trolleys are slightly deformed by the egg mass. So that is, they sit slightly lower to the ground compared to unladen trolleys. So we'll set up those trolleys, and what you're looking for is a nice uniform gap between those turning shoes and the turning plate. So that bottom plate that you can see on the slide now represents the turning plate that's mounted to the top of the trolley. And what you're looking for is a 5 to 7 millimeter gap between those two. You want it as close as possible without running the risk of interference when you're loading the trolleys into the machine or transferring them out of the machine. Now, by using a nylon plate or a metal plate or something with a uniform thickness to set those heights, you can ensure that you've got uniform height adjustment throughout your entire hatchery. Big advantage of this is you get uniform turn angles. A secondary advantage is it ensures that you've got the ability to interchange trolleys from one machine to another. Absolutely what you want to avoid is setting all your turn angles different between machines. You take the trolleys out of one machine, go to put them in another, and you run straight into that arm, because then you run the risk of having to, or you're necessitated to start dismantling your machine in order to get those eggs in. And in the entire time, you've got an incubation cycle to meet and operational needs to match. Once you've got that turn height set, you put the turn system in level, and what you want to do is set that level limit switch so that the icon, which you can see in the bottom right hand corner here, is illuminated on the touchscreen. That tells you that the control system is aware and it's recognizing that limit switch in that middle position, that level position. Now, once it's set there, you want to manually drive the trolley away from that limit switch and then put the system back in level through the control. That'll get the PLC to drive it back to level, and what you may find that it drifts ever so slightly away from that. So you want to adjust that level limit switch. Now, whenever our control is telling the system to go to level, we will always extend the turn system fully, so that is to turn the eggs away from the door and then go back to level. The reason for this is to accommodate for the small gap between the turning shoe and the turning plate, and it allows us to ensure that the trolleys are actually level. Now, if you try leveling from the other direction, you'll find because of that gap, your trolleys aren't entirely level. They're going to be 5 or 10 degrees out, which is entirely expected and normal. But when you come to try to transfer those trolleys, you may find at the very top of the eggs impact with those turn shoes. So that's something that's built into the control to accommodate for that. Now, if when you're setting these turning shoes to level, you have 11 turning shoes in an A12 that are absolutely spot on, nice and level, and one that isn't, you're going to want to address that. So that's either replacing the rocker arm or checking those link bars and the bearing blocks on the roof to make sure that they're all sound, so all mechanically sound, don't have any wear and don't have any damage. If you find some damage, as with the Classic, you're going to want to replace that hardware with known good hardware to get it back to where it should be. Once you've got the level position set, and you're absolutely sure that all the hardware is true, it's not bent, it's not deformed, and it's set in the correct location, and your turning shoe height is correct, you then want to do the same process with the extend and the retract limit switch. So here on the right hand side, you can see the two different styles of actuator. At the bottom, we've got the SKF, or the older actuator. Now, we moved away from this actuator for a couple of reasons. The first is because the price went up and we didn't want to pass that increase in price on to yourselves. And the second reason is we started getting reports of these actuators over a certain age, they were coasting. The problem with that is once it reached a limit switch, the motor itself would take power off it, but because of the momentum of the actuator and the egg mass, it would continue to coast past the limit switch. This can, in very rare conditions, lead to damaging eggs and the control system itself from pausing. So it'll stop the turn system. Now, you'll absolutely get an alarm, so you'll get a warning of that, but it was an undue annoyance that we wanted to design out of the system. So we switched to the actuator above that, which is the Warner actuator. Now, this is a great improvement on the SKF for two main reasons. 3 if you include the price. The first one is that it's got a built-in clutch. So if you have a mechanical jam in the machine, as I mentioned earlier, you would expect something in that machine to break. Something's got to be the weak point in that system, and something's physically going to deform or something's going to break. With the Warner actuator, it's got a built-in clutch. So the result of that, much like a chuck on a drill, If it comes against something that it physically can't move, you're going to hear that clutch activate, and you can hear a click, 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 is the motor saves the system from braking, and it doesn't transfer that inertia, that momentum, that torque into the machine. Second great thing about that Warner actuator, has got a built-in brake. So when we tell it to stop, it stops on a dime. It stops really quickly, and it stops it from overshooting those limit switches, which avoids you confusing the PLC and avoids you from potentially damaging your eggs as well. Now, your extend and retract limit switch, very easy to set. So they all come with little grub screws. You just loosen up those grub screws and then slide them up and down the shaft of that actuator. Those reed switches are triggered by a magnet, much like the bottom turning system, that's built into the actuator itself, and it's just a little rare earth magnet. And a change in the turn angle is simple as moving those reed switches either closer to the end to increase the turn angles, or closer to the middle to reduce them. Now, when you're measuring turn angles, it's always recommended that you measure the turn angles on the trolley itself. The reason for this is that gives you a great indication of what the egg's actually seeing. That's what we're interested in after all. It's no use measuring your turning shoes at 45 degrees if you're then losing 10 degrees between the turning shoe and the trolley, because what's important for us for great incubation is the angle that you're actually getting on your embryo. So as you set the turn system, so the top picture here is a good indication. It's a good representation of that gap between the turning shoe and the turning plate. And the larger that gap, the greater loss in turning you're going to see between the turning system on the machine and the turning system within the trolley. Now, once you've got the configuration correct on an Avida, that system's going to run absolutely fine for a decade or more. However, as with the Classic, you can have an amount of mechanical wear that you're going to have to rectify eventually. This usually comes around in these machines around 8 to 10 years, depending on how well the machine's been maintained. The first thing you want to look out for, and you don't want to have to wait 10 years in order to do this, I'd recommend doing it at least annually, is you want to check all of the link bars for any damage. So this is the link bars and the crank bars. Now, the reality is, if your link bar's been bent because of a mechanical jam, you would have noticed it as soon as it happened. The amount of space between these link bars on the roof of the machine is minimal. So if one of them's deformed, you'll hear it a mile away, and hopefully you would have noticed your loss in turn angle as well. Once you've checked your link bar, you want to be checking your crank arm and your rocker bars. So your rocker arms, to see if they're bent or deformed. Now, as I mentioned earlier, it's likely to be your crank arms inside the machine that are deformed as opposed to anything else. Once you've checked them, you want to be checking your hanger bars on the trolley themselves. Now, much like the Classic, the top of those hanger bars is where the bulk of the weight in your machine is being held. So that's where the bulk of the wear is going to be. And what you'll often find in hatcheries of 10 years older or more is those round holes at the top of the hanger bars who become elongated in their oval. In extreme examples, what you'll find is they've worn clear through the top of that hanger bar. A couple of problems with that. The first is it's robbing you of turn angle, and you may find instead of 45 degrees, you're getting 35 or 25 degrees. The second side of that is it puts all of the weight of that stack of eggs on the bottom of the trolley, which deforms the trolley and runs the risk of crushing eggs further down the stack. The reason that happens is that hanger bar is not meant to be structurally from the top down. The weight is meant to hang off it as opposed to being compressed. So that bar will bend slightly, which puts additional tension on the rest of the linkages within that machine. Now, within a trolley itself, the one side of the trolley is going to be your drive side, and the second side is going to be your slave side. Now, what I mean by that is we only actually turn one side of the trolley, and then that's linked to the other side by a link bar down the bottom of the trolley. If that link bar is worn or bent, and one of the common things we'll find in a hatchery is people use it to kick the trolleys around, so that is just to give them a little bit of momentum to start them moving, they're going to bend eventually. And as a piece of metal bends, A, it gets weaker, and B, it gets a little bit shorter. Problem with that being is you're going to find that although you might turn 45 degrees one way, when you're trying to turn the other way, one side of the trolley is absolutely fine, but because of that shorter link bar, you're only turning 35 degrees on the other side. So again, it's something really important to check at the bottom of the trolley. And if we come back up here, so your link bar is down the bottom of the trolley just here, linking two sides of the trolley together. So that's something really important to check periodically again, just to ensure that it's not been damaged, nobody's caught it on anything as they're going around the hatchery like a pallet jack, and nobody's been kicking it in order or using it as a push start to get the trolley moving. Now, electrical wear. This covers all machines, but especially on an Avida, because there's so many components that could potentially go wrong. If any of those components do go wrong, it's usually catastrophic for the turning system. So that is, it's going to completely stop the turning system from working. So this isn't something that you're not going to catch, and you're going to surprise you in 5-10 years time that, oh, I didn't realize that was a problem. It's physically not working. Easy way to identify this and ensure that it's fixed correctly is with the use of a preset checklist. Now, a preset checklist is something I always recommend, something we covered in great detail during the previous webinar on maintaining your incubators. Is a simple checklist that you go through to ensure the mechanical function of the machine is correct. Now, from my point of view, prior to any eggs being set in an incubator, that incubator belongs to the maintenance crew of the hatchery. And it's their responsibility to make sure that everything on that machine is fit for purpose before that machine's handed back to the hatchery staff in order for eggs to be loaded. And that's just a simple case of going through the engineer's menu and testing each of the functions, measuring the turn angles, making sure your cooling works, making sure your heating works. And if you spot a problem at that stage, it can save you potentially tens of thousands of pounds in egg losses a couple of days down the line. Now, if you do spot a problem, most of the components, well, all of the components are exceedingly easy to replace if you've got them in stock, which is why I always recommend any critical parts, so that is any parts that the incubator physically can't run without, are kept in stock and kept up to date. There's no point in having a replacement PLC on your shelf for 10 years if when you come to use it, it hasn't been tested, it hasn't been out of the box in 10 years, and the internal battery's flat as a result. So please keep on top of your spare parts, rotate them as necessary, and give us a call if you want any support with any of them. So just as a quick recap, how do you correct bad turning? Use a preset checklist. It's the best way of spotting errors before they become a problem. Whether it's preventative maintenance or reactive maintenance, by doing a preset checklist, you can keep on top of it and you can forecast your needs going forward. Carry out regular preventative maintenance. Replace bushings as needed. It's far cheaper than any alternative you're going to find. And if you don't have bushings built into your trolley because of the age of your equipment, give us a call, and by all means we can put together a proposal to include bushings. We expect our incubators to last 20 or 30 years. That's what they're built for. Your turning system's going to need maintenance during that period. If you don't carry out that maintenance, your incubator's not going to last as long as you want it to. Adjust your turning heights. That built-in adjustment that we've got designed into the machine, use it to your advantage. So if you've got a brand new hatchery and your concrete floor settles a little bit, or your epoxy floor settles and you lose 1/4 of an inch, adjust your turning height after 6 months to accommodate. If your casters lose a little bit of height as they age, adjust the turning shoe to make up that additional space so you can still maintain 45 degrees. That adjustment's built into the machine for a reason, and it's absolutely to your advantage to use that. Preventative replacement of components. Being called out in the middle of the night because of a breakdown on a relay or a motor is absolutely the last thing anybody wants. It's costly. It runs a massive risk of a loss in hatch, loss of production, and it's relatively simple to avoid. There's several components on a machine within the turning system, and as a machine as a large, that everybody knows are going to fail at some point. They're pretty much considered consumables on the machine. So this is things like your belt for your fan, your relays. These can absolutely be replaced on a schedule, whether it's 3 monthly, 3 yearly, and it can save you a lot of heartache in the long term when it comes to undue call-outs and loss of production. If you do spot something that's worn or broken, don't try and bodge it. Get that component replaced, get the machine running back to a good standard, and give yourself the peace of mind that that machine's performing just as good now as it did the day we first commissioned it.
Hey, Craig, this is Mark. If you could go back one slide. You mentioned there the annual parts kit, and let me just speak to that briefly. And while we're not primarily here to sell things on these webinar series, we just want to bring value to the hatcheries and to our customers through information sharing. The annual parts kit might be a program that folks are not familiar with. And with this APK, or annual parts kit, basically we send you every quarter those parts that typically wear out. And so along with instructional videos and on how to replace those parts, you can just set it up like a subscription that shows up every quarter, a certain number of parts based on your hatchery and the machines you have and the age of those machines. We've identified about 12 parts that are the ones that, as Craig said, are consumable. Those that we would expect you would replace over some cadence. And so over, say, a 6-year period, there's certain things that you should replace every year or every 2 or 3 or 4 years. And so we set up a schedule and just have those delivered to you every quarter. And so there's a consistent cost over 5 years for the length of your subscription, and consistent shipments that come every quarter to support you. So that's the annual parts kit program. And you can reach out to us at support@chickmaster.com anytime to find out more information or to talk about how that might be the right thing for your hatchery or not. So sorry for interrupting, Craig, but I saw the term there and wanted to jump in on it.
Yeah, no, it's not a problem. So the APK is a fantastic program we've put together. We've had a fair number of customers that actually came to us asking for it, asking for some guidance on exactly what it is they need to do for preventative maintenance. And now preventative maintenance is in recent terms has become far more important for hatcheries. Historically, it was seen as sort of a bad word within hatcheries because it was a cost that you were guaranteeing compared to a cost that you were potentially avoiding. However, there's been more and more studies over the last few years that show that preventative maintenance, at absolute worst, is a net gain. So that is to say, if you're replacing a relay or a belt inside a machine, that's not a sunk cost. It's not a cost that you're adding onto the machine. It's a cost that you're just doing a little bit sooner. But your deferred costs, that is your call-outs in the middle of the night, your loss of production, your loss of feasibility, are greatly reduced. So I'd always recommend preventative maintenance in the APK kit. The annual parts kit is a great way to do that. And that's a program that we tailor for pretty much every customer. So no matter how old your machines are or how often you want to replace equipment, we can accommodate you for that. The last slide here, I'd be glad to see, because I'm sure everybody's as bored of it listening to my voice as I am, is just a quick run through the tools that you're going to need to ensure you do successful turning inside your machines. So the first thing I'd always recommend every hatchery to have a handful of is a digital angle meter. Now we always use these DigiPass ones, which is the HRK003 available on our spare parts store. This is a great little tool, main reason being it's magnetic. So it'll give you a digital readout down to 1/10 of a degree. You can magnetize it onto the tray frame, which is the turn angle that we're most interested in inside the machine. And it's very quick to run around an entire machine or an entire set of trolleys to gather all those turn angles. Now, every single webinar that I do, every time I sit down in front of a customer and talk about maintenance, I always stress the importance of keeping records of what you do. It's all well and good measuring your turn angles, but if you're not writing it down and tracking that deterioration in turn angles over multiple years, you don't know where you're at. So if you go around your machines today and find out that you're at 37 degrees, you've got no idea how long it's going to take for that to deteriorate down to a point where you have to take action. Whereas if you've got 5 years of records and it shows maybe a degree a year being lost due to wear and tear, suddenly you're put in a position where you can plan your maintenance in a time that suits you, as opposed to suddenly having to turn around 1 year and go, right, we have to spend loads of money this year and have loads of downtime in order to rectify this turn system. Second point on that is a spirit level, or just a straight edge, to ensure, especially on the Classic, that your turn system is plumb and correctly aligned. Thirdly, some suitable lubricant. So if you've got bushings and bearings in place, you can largely ignore lubricant, but if you've got metal on metal, just some machine-based lubricant, some metal on metal lubricant can save you a lot of heartache in the long run. And then a standard toolkit. Now it sounds silly, but a lot of people, when you need an Allen key in a hatchery, can't find the correct size. So having a toolkit specifically set aside with the correct tools in that you need for your turning system can save you a lot of bother at 3 a.m. in the morning when you're looking for that 3mm or the Imperial Allen key that you need for that 1 grub screw. So that covers Chickmaster's turning systems. Quite happy to take any questions that anybody's got on that material.
Yeah, thanks, Craig. Everyone can look at the Q&A button. There's been several questions have come in over the hour here, and we've been answering those through the chat. We'll send out a transcript of those to everyone at the end, alongside a recording of this. Craig, one that's unanswered at this point. Any recommendations on A24 units that are so deep it's not possible to see all the trolleys in the back from the windows? So how can we have how can we check if we have any problematic trays in larger units?
So the biggest trick with an Avida, especially the A24s, is a step ladder. And it sounds ridiculous, but I agree. Because of the height of the machines, especially when you get to the 16, 17 stack height trolleys, it's very difficult to see all the way down to the back of the machine. But if you get yourself a step ladder so you can get to the top of that window in the front of the door, or even just to the top of the trolley, if you're not fortunate enough to have windows in the setter, to put your eye level at the top of the trolley, and you can see straight down to the back of the machine. And what you're looking for is the top of those hanger bars when the trolley's turned. They should be in a nice straight line. They should all be roughly at the same height down the length of the machine, down the length of the trolley. And that's really the only way you're going to be able to check turn angles for every single trolley once it's fully loaded. However, if you're successfully doing and you're carrying out a preset checklist, there's no reason to believe that your turn angles won't be good when the trolley's loaded. If you're confident that your crank arms, your link bars, and your rocker arms are all correct prior to putting trolleys in, and you're staying on top of maintenance of your trolleys prior to them being loaded, that check's just there as a backup to ensure nothing else has been missed. But if you've got confidence of your turning system in the machine before you put eggs in, you're good to go.
Thank you. All right, are there other questions? I'll give you just another moment to answer those. You mentioned in most of these webinars, Craig, you've talked about a preset checklist. That's something that they are often in the manuals that you got during the commissioning of machines, but that's also something that we can send out to you, some of those things to our customers. Is that correct?
Yeah, absolutely. So if you go on the webinar section of our website, and if you look for the webinar on incubator maintenance, which is one of the first ones on there, just after the COVID-19 hit, we've actually got an example of a preset checklist, which is the one that was included in our presentation here. So that's a PDF that is freely available to anybody here. And that runs through a standard Avida. It covers a couple of topics on a Classic as well. And they're the critical components that we consider you need to check prior to putting any eggs in a machine. And it's the equivalent of checking your tire pressure in your oil in your car before you go on a long drive. And it's something that to us is absolutely critical prior to putting something as expensive as eggs into an incubator.
We have a duck hatchery asking a question. When doing a preset maintenance check, do you recommend using trolleys with eggs on it?
Absolutely. See, there's a certain amount of checks that you can do on turning system with an unladen trolley, but the reality is once you've got 500 kilograms or around half a ton of egg mass into a trolley, that trolley behaves very differently. So it's going to sit slightly lower on the casters. The framework's going to alter shape ever so slightly, almost imperceptibly. But if you set an empty trolley up to say 45 degrees at the perfect turn height, and then put half a ton of eggs in that same trolley frame and load it into the same machine, you're going to get a slightly different result. So you can get it 90% of the way there with an empty trolley, but I absolutely check whatever you're doing with a fully loaded trolley as well.
Okay. Another question about Classic machines. Thank you for that, Craig. And Deb, I hope that answered your question. Another on Classic machines, Craig, is it a problem when the left side and the right side angles are different, but the total turn is still the same? So if it's still turns, say, 80 degrees, even if it's, say,
Yeah, so we're very quickly into the realms of embryology, which isn't my specialty.
Okay.
So I'd highly recommend you send this question through to support@chipmaster.com. But what we'll do is I'll get Chad Daniels to contact you. But the biggest problem you're going to get is if you say getting 35 degrees one way and 40 degrees the other, your cannulate membrane on the inside of the eggshell isn't going to develop uniformly within that eggshell, and that's going to have a detrimental effect. I believe, and I may be speaking out of turn, that you're better to have worse turn angles but equal both sides left and right than you are to have non-uniform turn angles left and right. But it's something I'd absolutely send a question through to us. Unfortunately, I see you're anonymous on here, but drop us a note and we can answer your question specifically.
All right, wonderful. Well, everyone, I'd like to thank you again for spending this hour with us. If you have other questions, email them to support@chipmaster.com. We're here all the time to answer your phone calls or your emails to help you get the best performance out of your hatcheries. we are just starting to travel again as different states are opening up. And so if you need one of us to come and visit your hatchery for some consulting, we would love to do that and to see you in person again soon. Next week, we're having this same webinar in Spanish for our Spanish-speaking customers, and then we'll be posting shortly a revised list of upcoming webinars. We have so many topics that you have requested, and we hope to service as many of those as possible in the weeks to come. So Craig, thank you so much for sharing with us today, and thank you to all of our guests. We really appreciate y'all being here. So have a great day. Take care.